Graphing compound inequalities. At the end of this lesson, you should be able to answer the question, what are compound inequalities and how do I graph them? So, I want you to first think about what is the difference between the word and or. And let's look at this with a Venn diagram. If I have two sets, set A and B, and means the intersection of both A and B. So what area do A and B have in common? Well, it would be this overlap shaded region. Whereas if I think about or is the union of two things. If I say something is in either A or B, it doesn't matter where it is. I take everything in A, I also take everything in B. I don't have to worry about anything that overlaps. In mathematics, an and is known as a conjunction, whereas or is known as a disjunction. So let's consider this in the idea of a compound inequality. Here's a very simple one. X is less than 4 and x is greater than or equal to 2. Well, if we first consider the graph of x is less than 4, this would be an open circle on 4 and shading all the values to the left. Whereas x is greater than or equal to 2, this would be a closed circle on 2, and I'd shade everything to the right. Well, if these two statements are joined by the word and, it's a conjunction, I'm looking at where do these two number lines intersect. So if I combine these two graphs and I put one over top of the other, it's where that blue and the green shaded region intersect one another. Where do they intersect? So it would be a closed circle on 2 and an open circle on 4, and you're shading the region in between. I'm going to show you an alternate way that an and can be written. I could have the x in the middle, the smallest number on the left, largest number on the right. This is the way I prefer to write compound inequalities if it's an and then the x is in the middle. It looks to me the way the number line is shaded. Normally they're red from the middle. You would still read this as x is greater than or equal to 2 and less than 4. Now, let's consider the difference between this and an or. If I take these two statements and join them with the word or, first of all, I graph x is less than 2, open circle, shade to the left. Then I graph x is greater than or equal to 4. That'd be a closed circle on 4, and I shade the values to the right. I combine my graphs. Now, with an or, I do not have to worry about where anything intersects. It's just everything from both statements placed on the number line. There's no alternate way to write an or. Okay, so let's just do a quick practice problem. For the first, x is greater than 2, negative 2, and less than 3. So I'm simply going to set up my number line. I'm going to put negative 2, negative 1, 0, 1, 2, 3, etc. So the way this is written, this is an and. It could not be an or. Only ands are written like this. So this is going to have an open circle on negative 2 and an open circle on 3, and the values that are in between both is what I need to shade. In number 2, this is a disjunction or an or. I'm going to put negative 12 on my number line, and I'm going to count by 4s. So I'm doing negative 12, negative 4, negative 8, negative 4, 0, 4, 8, 12, etc. Okay, so if x is greater than 4, that's an open circle on 4, and I shade all the values to the right. I do not need to worry about where anything intersects. For x is less than or equal to negative 12, it's going to be a closed circle, and I shade all of these values to the left. So just kind of compare the two graphs. The one on the left is the most common way that you'll see an and ors often look like the one on the right. The graph on the right could never be an and vice versa. Okay. Let's just do one more additional step where you're given a verbal statement and you have to translate it into a compound inequality and then graph the solution. So this says all real numbers that are greater than or equal to 8 and less than 30. So the moment it's an and, I prefer to write it in this nested notation where x is greater than or equal to 5, which is also 5 is less than or equal to x, and at the same time less than 30. Notice with this and how the symbols end up going the same direction. Okay, so I'm going to graph these values that make this statement true. So I'm choosing to count by 5s on my number line. So I'm going to need an open circle on 30 and a closed circle on 5, and I shade all the values in between. In number 4, all real numbers that are less than -1, so I say x is less than -1, or I must have the word or written. In number 3, and is implied by the way it's written. Here, or must be written out. Or x is greater than or equal to 15. So I chose to number my number line by 2s. Just makes it easier for me to fit everything. So I'm going to graph everything less than -1, so it's going to be an open circle on -1, shade to the left. For x is greater than or equal to 15, this time it will be a closed circle on 15, and I shade all the values to the right. Okay, so now we're going to do some combining of solving and graphing. So in number 5, here it says 1 is less than 2x plus 5, which is less than 9. I typically read these from the center. I say 2x plus 5 is greater than 1, and 2x plus 5 is less than 9. In this compound inequality, you can work both inequalities at the same time, meaning I really have 2 here, and my goal is to get the x alone in the middle, so I'm going to subtract 5. If I subtract 5 on the middle, I have to do it from the left inequality and the right, which results in -4 is less than 2x, which is less than +4. Then I divide each side by 2 to get the x alone in the middle, and I get -2 is less than x, which is less than 2. So here's an and I'm going to graph this on the number line. So 0 in the middle, here would be -2, and here is +2. I'm shading where these two graphs intersect. So if x is less than 2, open circle, and x is greater than this -2, it's going to be the region in between. In 6, this is an or. I need to solve each inequality separately, so I subtract 3. Remember, at any point, if you end up dividing by a negative or multiplying by a negative, you must reverse the direction of the inequality symbol. All right, so I got x is less than 3 on the first. On the second, adding 6 to both sides, I get 3x is greater than 18. Then I divide each side by 3, and I'm dividing by a positive, so there's no need to switch. So I get x is less than 3, or x is greater than 6. So I'm putting some numbers on my number line. And I will have a closed circle on 3. And I shade all the values less than 3. Since it's an or, no need to worry about any overlap or intersection, so it would be all values greater than 6. 7 is an and. It's just written out rather than in the nested notation. So let's solve this. We're going to solve each one separately and then graph the intersection on the number line. So we're going to divide by 2, which gives you x is less than -3, and divide by 3. Again, it's not necessary to reverse any symbols. X is greater than or equal to 4. So if I take my first one, let's see, and put my numbers on my number line, I'm going to put -4, -3, -2, -1, 0, 1, oops, 2, 3, and 4. For x is less than -3, that's an open circle, and I shade to the left. And for x is greater than or equal to 4, it'd be closed circle, and I shade to the right. However, I've got to think about, where did these two graphs overlap? They don't. So this graph is not the solution set. That would indicate an or. This is an example where there is no solution, because there is nothing that fits both conditions. One last one here, slightly more complicated one where we have variables on both sides. So I need to subtract h from each side, which gives me negative 3h minus 7 is greater than 5. Then I add 7 to both sides, and I get negative 3h is greater than 12. Then I divide by negative 3. And when I divide by negative, I have to remember to reverse the direction of the inequality symbol. So I get h is less than negative 4. In the second part of this disjunction, I need to distribute the 1/4. So I get 1/4 h plus 2 is greater than or equal to 9. Subtract 2 from each side, and I get 1/4 h is greater than or equal to 7. Finish it by multiplying by the reciprocal, so I'm going to multiply both sides by 4, and I get h is greater than or equal to 28. And I put my word or here for my solution. So h is less than negative 4 or greater than or equal to positive 28. So I'm going to number my number line 0, 4, 8, 12, 16, 20, 24, 28, 32. So I'm counting by 4s. And I just realized that that's negative 4, not positive 4, but that's okay, it still fits. Going to put an open circle and shade to the left. Or x is greater than or equal to 28, so closed circle, shade to the right. And now you should be able to answer the question, how do I solve and graph compound inequalities?